The atomic mass consists of what, Jalen?
Protons and neutrons.
Protons and neutrons. And the reason why the proton's important is because it controls, what did you say again, Brandon?
The appearance.
Right, the appearance. So we're trying to make more gold. All of the electrical wires that control your automobile's airbag, that's gold. Why would it be gold?
Because it resists corrosion.
Well, resist corrosion, so it's going to last the longest.
Really?
Yeah, you want the airbag to last a long time. You don't want it to, like, 10 years from now just not work anymore.
When your airbag explodes, you like replace it or like can you like spread?
Yeah, all that has to be replaced. Now, just to show you a visual, right, just copper, how corrosive it is. Like if I were to open this up, you can see there's corrosion on the wires. See the corrosion in there? So making it out of copper it's going to corrode in 10 years. The gold is the best thing to make it out of. That's what they make it out of gold.
You know how like some like batteries?
William Crookes noticed a flash of light within one of the cathode ray tubes. A green flash was produced by some form of radiation striking the zinc sulfide coating that had been applied to the end of the tube. Further work showed that there was a radiation going through the tube.
Maximum
This
points.
ray originated from the cathode and traveled to the anode. Was called a cathode ray. The accidental discovery of the cathode ray led to the invention of television. A conventional television is nothing more than a cathode ray tube. Scientists continued their research using the cathode ray tubes, and they were fairly convinced by the end of 1800s of the following. Cathode rays were stream of charged particles. The particles were carried a negative charge. The exact value of the negative charge was not known. Because of the changing metals that make up the electrodes are the gas at very low pressures in the cathode ray tube did not affect the cathode ray produced. Researchers concluded that the ray negative particles were found in all forms of matter. These negative charge particles that are part of the forms of matter that are known as electrons. Some of the experiments used to determine the properties of the cathode rays are shown in figure 4.7.
Okay, so Amir, tell us what substance did the cathode ray strike in a tube? No, all right, Daniel. Yeah, the zinc sulfide. You're going to want to write that down in your notes because it's helpful to understand. Like, if you're interested in TVs, which a lot of people are, we don't make that many anymore in the United States. A lot of that's because of tariffs, and Trump's trying to fix that. Yeah, so the same thing with cell phones. We don't assemble any of those. Now, the largest cell phone maker in the world, does anybody know who that is?
Samsung.
Raise your hand.
Samsung.
Samsung, where are they located?
China.
Japan? No.
Korea.
America.
Yeah, there's South Korea. So Samsung, it's like a dynasty in South Korea because they make so many different things, Samsung does. Now, the Chinese don't really like the South Koreans. You didn't know that because they kind of support North Korea.
We gotta figure out.
The atomic mass. All right, Hunter. Yeah, the protons and the neutrons. And what do the protons control again?
Looks.
Yeah, the looks, the appearance. And that's really important for us because we want to try to make more gold. That's been the goal since really chemistry started, alchemy. If you remember Henning Bratt, he was trying to make what?
Gold out of heat.
Yeah, gold out of his urine. The golden flow, he was like trying to make that gold there. And to this day, we haven't figured it out. Will we eventually? Yes. It's just, right now it's technical because you have to have platinum to make gold, and platinum's more precious. So it'd really be nice to make more platinum because it has a lot of uses. Specifically what? Anybody know where you can use platinum? Catalytic converter, where else? job, Will. Raise your hand, I'll give you points. All right, Hunter? Computers, platinum. They really want to use gold in computers because it's resists corrosion and it has really, really high conductivity. It doesn't heat up real easily. So it's a nice thing about gold. It's in all of your wiring for your airbags. So in your car, automobile airbag, because copper corrodes, and you wouldn't want that to corrode if you get in an accident and you want your airbag going off, right? So that's why the airbags are really expensive, because it's got gold wiring in it. But platinum, where would we use platinum? Nice thing about platinum, it also resists corrosion. There was a guy who came up with the artificial leaf in Harvard, and he found a way to make hydrogen without platinum through the electrolysis. So if you want to make hydrogen from water, you need electricity to do that. But also, if you want to take hydrogen and make electricity, you need platinum. So platinum is just a great catalyst for that. It just works well with automobiles. When you look at carbon monoxide to carbon dioxide, it just has a certain characteristic that's really nice. So if we can make more of that, then we would be promoting our future in hydrogen power. We'd be getting away from fossil fuels. Thompson, magnet. Magnet using the cathode ray. Raise your hand if you remember. So if we turn back to page, or 110, if we go forward to page 110, it shows you JJ Thompson's plum pudding model. And what does it prove in the plum pudding model? Page 110. Raise your hand. Raise your hand. Now, the difference between like an honors or a regular student and an advanced students hate what? No, they hate to be told the answer. They just despise that totally. You know, if I tell you the answers, you're just like, hey, you want to figure things out. That's how you get into like the Gates program. There's a Gates program, like the Duke TIP program. They basically give you tests and see how well you figure things out. And it's kind of like an IQ test type thing. So keep in mind, if I'm telling you stuff, you're going to like hate me. I'm always telling you the answers, which I'm not doing right now. I just want you to tell me, what did JJ Thompson do to figure out?
He stated that the atom is a uniform positively charged sphere containing electrons.
Right, so it contains electrons, and how did he prove that it contained electrons? The magnet is independent. I had a magnet in here that I took it back in the lab just so I wouldn't lose it. But the magnet will stay. Raise your hand if you've never touched a magnet before. Okay, so you've experienced a magnet before, and there's just something coming out of it that nothing's being added to. The magnet has an independent characteristic, so when you stick it on like a file cabinet, it stays there without adding anything to it. So he was trying to investigate what was coming out of the magnet. And he proved what was coming out of the magnet was the same in the cathode ray. So he's like, okay, well, if these are electrons, then the electrons must be in the structure of the atom. And that's what they're showing here. He only could promote a model with the electron. That's all that he proved in his experiment. Make sense? All right, so keep that in mind when you progress on to colleges. Colleges do a lot of cool things to make their campus look nice, but majority of what they do at the undergrad level is just test whether you understand the material. And that's boring for a lot of people. For your advanced student, they don't want to do that. They want to kind of figure out, what's next. Like the Bill Gates type people. They're impatient. They want to get in there and, solve stuff. And a lot of them drop out and then start their own businesses and whatnot. So keep that in mind, that it is a struggle to, if you're smart and advanced, to study the material, consistently, repetitively, like sports, doing the same thing over and over again. It's not easy to do that. Containers. And you're going to try to figure out what's inside the shape. Now let's get somebody to read for us where it says all science. Okay, Nydia.
Wait, where are we reading?
At the top of the page it says all science is an attempt to understand.
Okay.
No, it's this page right here. This is what I gave you when you came in. So we just read about the cathode ray and Cook and television. So no application there. Go ahead.
Okay. All science is an attempt to understand and explain the world we live in. Investigators, scientists, and researchers have sought to explain the incredible amount of
Numbers on the bottom of the plates. So you can just peel it down to see the number. Somebody wrote on this one that there's a 4. So you can peel the number down. Does everybody see that? So you're not doing the same container over and over again. Now, how many times do they want you to figure out the shape? Twice. So you'll see a hypothesis, then you're going to see a retest. So hypothesis just kind of like a quick guess, and then the retest when you go maybe a little bit slower, maybe use another sense, maybe hearing a little bit better. And then the last one, you're going to open it up, and you're going to look inside, and you're going to write down what the actual shape is. So you can see how this one has a shape to it. Everybody see that?
yes.
And you're going to see how close you are to that. Now, if you have like good IQ and good ability with your hands and touch, you'll be able to figure these out. They're not easy to do.
Are we figuring out the shape, like the object inside of it, or like?
You're figuring out the pattern. So inside of it, there's a pattern, a shape or a pattern, and you want to be able to draw that pattern in your hypothesis and your retest, and then you open it and see whether you're close. I would circle the ones that you're close on. Circle the 2 that you're the closest and say, this was my best attempt. Now what I'm looking for in this, there are 7 senses. I want you to tell me which of the senses you used to determine the best answer that you got. So each one might be a little different. As you do the 15th one, you might be using more of the senses. Now you're probably familiar with the first 5. Anybody ever heard of the first 5? All right. What about the last 2, the vestibular? What does that have to do with? Raise your hand. What does vestibular have to do with? It has to do with. Starts with a G. Yeah, gravity. So it's a sense associated with gravity. And what about proprioception?
It's like, I think since you're how it sounds like you can see like where it's gonna move before it's like you can see like where the action's gonna go.
Okay, it's your body's interaction. Close. It's really your body's interaction with its environment. Specifically, they're saying, is the sense of the relative position of neighboring parts of the body and strength of effort being employed in movement. So you're going to have some of that happening, determining the shape of the particular diagram. So write down the senses you used and see if you're using more as you progress and maybe get the right answers. They used to have these as toys when little kids, like when I was growing up, stuff like that. And then if you do, they kind of designate you like a Gates child because you can use your senses. How many senses are there?
5.
There's actually 7, really 8. But the 7 we're going to associate with today are up on the board. And we want you to write these down. You have the sense of smell, sense of hearing, taste, touch. Abby, what else?
Sight.
What else?
Vestibular, I don't know.
Vestibular, what does that have to do with vestibular? Gravity. And then what the proprioception? Proprioception. What's that have to do? How your body interacts with the environment, other body parts. Like you could use both your hands to try to figure out the shape. So let's read first.
Wouldn't that be cute?
I think it's kind of a combination of 2. The way the book describes it, or the internet says, Proprioception is the sense of the relative position of neighboring parts of the body and strength of effort being employed in movement. So the strength of effort being employed in your movement, that's really what's going to be coming through on this particular activity. You are going to be doing that because you've got to hold the apparatus a certain way. The strength of the effort is going to be associated with your balance. All right, so let's get somebody to read there first, the first paragraph in this description. I read there where it says, all science. How about Daniel?
Yeah.
7 cents. How was acceleration calculated? Abby? Distance over time. That would be velocity. Would you have it's a vector quantity, so you'd have to have also the direction. So we have the magnitude, which is the number, right? The magnitude, which would be the distance divided by the time, which would be velocity. But how is acceleration calculated?
Would you need to know the rate of increase?
Okay, so rate is what?
The increase in speed that you're accelerating at?
Okay, Justin?
Two velocities over your time.
Right, so it's a change in velocity.
Yeah.
So the formula for that would be what? A equals
Distance 1 over...
final velocity minus initial velocity. And that's divided by time. Now you might want to write that down, because many of you might not know that. Now if you have a situation where velocity is changing rapidly, what does that mean?
You got rapid and...
If you have a situation where velocity is changing rapidly, what are you going to have? You're going to have a big acceleration. If you have a situation where velocity is changing slowly, what are you going to have?
Slow acceleration.
Slow acceleration. I believe you're going to get it right.
You believe? I'm not going to get it right.
It's a three-sided dot.
So I would say.
Now make sure you put the unit there. Once again, if your mass is not kilogram and your acceleration is not meters per second, you're not going to get what unit? The Newton. This is equivalent to the Newton. This is representative of the Newton. The kilogram meter second square is a Newton. Everybody understands? If you don't, write that down right now. This is representative of a Newton.
Meters per second squared.
Right. So if they're asking you for a force and you have Newton only in the answer, then it's going to be kilogram meters per second squared.
Oh, it's force divided by Newton.
No, he's just multiplying the two. Because that's the formula. Force equals mass times acceleration. Force is still going to be a tension. The force of tension. Now the problem is, this part he left out a portion of the problem where it says, how much tension must a cable withstand if it is used to accelerate a 1,200 kilogram car vertically upward at 0.7 meters per second squared. So this thing is going upward. And because it is moving upward, you have the force of gravity associated with it. So you're going to use a formula for that, and gravity is going to come in. So what do you think variable is going to come into play here? And what unit would that be?
9.8 meters per second squared.
Right, so you have to add that to this right here. Plus 0.7 meters per second squared. Now why must you add this?
Because that's a constant.
Because, yeah, the units are the same. That's all you can do
The constant's not
to keep the units the same so that you get a force. Because the units, remember, for force have to be meters per second squared and kilogram to give you the Newton. So if you've got a particular problem that's messing around with moving something up and down, you're going to be associating it with acceleration.